2. I told you could use substitution or elimination on these. So when you have 3 equations, typically substitution is going to be faster, or sorry, elimination is going to be faster than substitution with 3 equations. So we take 2 at a time, and we want to eliminate a variable. It does not matter which 2 equations and which variable you start with. So what do you want to do? First 2, and eliminate Z. I heard Z first. So if I want to eliminate Z, I have to take this one times 4. So the first one didn't change. So we get negative 10x plus 19y equals 19. Now I have to use the third equation because I have not used it yet. I have to use it with one of the other 2 and eliminate z again. So which one would you like for me to pair it with? If I'm going to eliminate z, which would be easiest? Second one. I just need to take that second one times 2. So we get negative 6x 10y minus 2z equals 10. So when I put these together, we have negative 4x plus 13y equals 13. Now, both of these equations have x and y in them. So I can put those 2 together and eliminate something. What do you want to eliminate? The x. Okay, so I have a negative 10 and a negative 4. I could turn them both into a 20. So I could take this one times 2 and this one times negative 5. So when we put those together, these cancel. I get negative 27y equals negative 27. Divide, so y is 1. Alright, now once you have y, it's just a series of working backwards to get the others. So maybe I'm going to go to this equation. If I plug in 1 for my y, so negative 4x plus 13 equals 13. Subtract over the 13. We get x equals 0. So now x is 0 and y is 1, so we can go back to the beginning and plug it in for any of them if I just did the first. So we get negative 1 plus 4z equals negative 1. 4z equals 0, so z is 0. So x is 0, y is 1, and z is 0. How can you always check yourself? Plug them back in. You would have to put all of them into all 3 equations to double check it. Is that one okay? Let's look at number 3. Would substitution or elimination be easier on this one? Yeah. It doesn't matter, but since we already have the first one as y equals, I might as well sub that into the second one. So if I plug that in, we have 2x plus 2 times the negative 3x plus 3. So negative 4x plus 6 equals 1. Subtract your 6. Divide by negative 4, so x is 5 over 4. So then you have to plug that back in. Easiest way is probably the first equation. So from here, negative 3 times 5/4 plus 3 is negative 3/4. Is that one okay? Number 4. So this one is using a matrix. So my first row is 2, 3 equals 10. Second row, negative 3, whoops, 1 equals 18. And when we go through these matrices, we have to start in the top corner, and we need to turn that number into a 1. So we have to think through how to do that. What would we need to do first? What could we do? Okay. It doesn't always give you the nicest answer, but it always works. If you need a 1, just multiply by the reciprocal. So it's a 2, so I'm going to take that row times 1/2. So 2 times 1/2 is 1, 3/2, 5. All right, we have to finish this column before we move to the next one. So now I need this number to be a 0. So to get a 0, you're always starting with that row. So row 2 equals row 2. It's a negative 3, so we have to add 3 of row 1. So we're not changing the first row. Negative 3 plus 3 is 0. 1 plus 3 times 3/2. You can grab a calculator if you get hung up on that. 1 plus 3 times 3/2. And that gives us 11/2. Next one we have 18 plus 3 times 5. So that's 33. All right, so the first column is good. We need to get our second column now. So you start with the 1. I need this number to be a 1. How do we always get a 1? So row 2 equals 2 over 11, row 2. So the first row stays the same. 11 over 2 times 2 over 11 is 1. 33 times 2 over 11 is 6. Now we need the 0. So to get a 0, that's row 1. So row 1 equals row 1. It's a positive 3/2, so we have to subtract 3/2 of row 2. So row 2 is not changing. So we have 1 minus 3/2 times 0, which is 1. 3/2 minus 3/2 times 1, which is 0. 5 minus 3/2 times 6, which is negative 4. So x is negative 4, y is 6, and that's our order there. So we're okay with number 5, the other matrix question? was asked about was number 7. So we're into the nonlinear systems. Okay. We still use substitution and elimination here. So what do you want to do? Okay. So we have 2x squared plus 3y squared equals 30. And this would be negative 2x squared minus 2y squared equals negative 26. So when we add 3 and negative 2 is just a 1y squared equals 4. Get rid of a square, use square root. With that comes plus and minus. So y could be positive or negative 2. Once we have one variable, we can plug it back in to find the other. So if I plug in a 2, I'll do the second equation. So y is 2. So we have x squared plus 4 equals 13. So x squared is 9. Square root plus and minus, so x could be positive or negative 3. So what we found is that when y is 2, there are 2 possible answers for x. So that gives us 2 ordered pairs. We have 3, 2, and we have negative 3, 2. If y is negative 2, we have x squared plus negative 2 squared equals 13. And what happens? Same thing. X could be positive or negative 3. So, when y is negative 2, we also have 2 possibilities for x. So we get a total of 4 answers on this one. Okay. Number 8. Does elimination really work on this one? Not really, because when you look at it, we have an x squared, but this is an x. This has an x times y. This has a plain y. It has a y squared. So substitution isn't, or elimination isn't really going to be much help here. Let's try substitution instead. So if we go to the second equation, we can solve for x. So if you add that 3y over, x is 3y minus 2. Then you can substitute that into the first one. So x, 3y minus 2 squared, plus 2 times x, which is 3y minus 2, times y, plus y squared equals 4. How do you do 3y minus 2 squared? FOIL. So if you write it twice in FOIL, you get 9y squared minus 6y minus 6y, so minus 12y plus 4. This one, I'm going to distribute the 2 and the y. So we get 6y squared minus 4y. So add like terms. 9y squared and 6y squared is 15y squared. Negative 12y. Oh, I forgot a y squared, didn't I? Got that one too. About 16y squared. Negative 12y and negative 4y is negative 16y. What now? When I subtract over my 4, those drop. So greatest common factor, we can take out a 16y. Leaves us with y minus 1. And so we get 0 and 1 for our solutions. We need x. If you look back at the beginning, we already said x is 3y minus 2. So we get 1, 1, and negative 2, 0 for the solutions. Let's look at problem 10. So we have to graph these. First one, this would be a y-intercept of negative 2. Slope of 1/3, so f1 over 3. Solid or dashed? Solid because it has an equal to. Alright, the second one. What's this a graph of? Parabola. How does it open? Down. What's my y-intercept?
16.
What are my x-intercepts? 4 and so that allows me to get a few points. Solid or dashed? Okay, so I've graphed these two. Now we need to figure out our shading. For the line, are you shading above or below? Below. If you didn't remember how to do that, you could always do your test point, 0, 0. So you get 0 is less than or equal to negative 2, which is false. So you can't shade 0, 0, so that means you're shading this other side. For my parabola, okay, it's harder to just look at it and know, but if you did your test point, you get 0 is less than negative 16, which is false. So where would we shade here? Yeah. So we are shading under our line, but outside the bracket. Did I have it wrong on mine? I did. I copied my problem down wrong when I wrote it over. I flipped one of my inequalities. I had the shading wrong on my answer key. I shaded the wrong side of my parabola. I had flipped my inequality there. Wait, no. I made a mistake here, didn't I? That's positive. positive 16. That's what I did wrong. So 0 is less than 16. Is that true or false? That's true. So, the shading's off here. 0, 0 does work. So you're shading inside your parabola. So we need to be inside the parabola but under the line. Sorry about that, guys. Is that one okay? Let's look at number 12. Okay, I asked you to solve for A here. And my whole goal with this question is just for you to understand a matrix. It doesn't really change how we solve it. It's still like solving any other equation. We have to get the A by itself. On the left, what does that 4 do? We distribute. So we get 12 minus 16, 8, 20, negative 4, 24. What would I need to do with this matrix? Okay, so now to subtract matrices, you just subtract each entry. So 12 minus negative 3 will make 12 plus 3 or 15. Negative 16 minus 2, negative 18. 8 minus 5 is 3. 20 minus 1 is 19. Negative 4 minus 0 is negative 4. 24 minus 4 is 20. Then how do we finish it? Yep. We need the A by itself. So we divide every number by 2. So we get 15 halves, negative 9, 3 halves, 19 halves, negative 2, and 10. Nobody asked about 13 and 14, but I know that Friday that was something that we were struggling with a little bit with the multiplication. So would you guys mind if I worked those out? Just kind of refreshed your memory on how to multiply matrices. Okay. So to decide if you can multiply, you have to look at the size first. It's rows by columns. So rows are horizontal, columns are vertical. So this one has 3 rows, 2 columns. This one is 2 rows and 2 columns. If these are the same, you can multiply them. This tells you how big your final answer will be. So my final matrix will have 3 rows and 2 columns. Okay, if you get stuck on this, think in terms of where things are in the matrix. This is row 1, column 1. This is row 1, column 2. This would be row 2, column 1, row 2, column 2. Row 3, column 1, row 3, column 2. You guys understand where those came from? That tells you what to multiply together. So to get row 1, column 1, I'm going to take row 1 times column 1. So you're going to do 1 times negative 1 plus 2 times 2. So you get negative 1 plus 4, which is 3. Okay, and then we just keep moving through here. So now we have row 1, column 2. So I'm going to take row 1 times column 2. So 1 times 0 and 2 times 5. So we get 0 plus 10, which is 10. Is everybody with me? Alright, next up. We have row 2, column 1. So I am taking row 2 times column 1. So 3 times negative 1 plus 0 times 2, which gives me negative 3. Row 2, column 2. So that's 3 times 0 plus 0 times 5. And we get a 0. Row 3, column 1. So negative 6 times negative 1 and 5 times 2. So that's 6 plus 10, which is 16. Last one, row 3, column 2. So negative 6 times 0 and 5 times 5. So 0 plus 25 is 20. Does that help? Do you guys need me to do 14 or do you understand? Let's look at 15, the last one. I think we might have done this one in our notes at one point. Linda won $200,000 in the state lottery. She first paid an income tax of 30% on the winnings. So did she actually receive a check for $200,000? No. So to figure out what she has left, when I was looking the other day, most of you figured it out by finding her tax first. So you did the 200,000 times the 0.3 and got 60,000. So then the amount she had left, you just subtracted those. And you get 140,000. You could have also thought of it as she keeps 70% of it, so just take 200,000 times 0.7, and that works as well. She is going to invest some at 1.5% and some at 4%. So you have to define your variables. So X, I'm going to say the amount at the 1.5. Y would be the amount at 4%. And she earns $4,350 interest per year. So now we have to write some equations. What's my first equation going to be? X plus Y has to equal how much money she had? 140,000. What's another equation? To find your interest, you take your amounts times their percents, add them together, and that equals our total interest. So then this is like a substitution elimination question. Let's eliminate Y. So I could take the first one times negative 0.04. Add those together. we get negative 0.025x equals negative 1,250. Divide 50,000. How would I find my y? Plug it back in. We know that x plus y, so 50,000 plus y equals 140,000. So x is 90,000, and then if it's a word problem, I expect a sentence. So Linda invested $50,000 at 1.5% and $90,000 at 4%. What other questions?